Imagine Earth as a baby, not the baby we know today, with its blue oceans and green continents. Picture a fiery, chaotic ball of rock, constantly bombarded by asteroids. This was Earth over 3.5 billion years ago, a time before time as we know it. Volcanoes erupted, spewing lava and toxic gases. The air was thick, the land unstable, oceans churned, still forming. This was a hostile and unforgiving environment, yet within this chaos, the seeds of life were about to be sown. The very building blocks of life, simple organic molecules, began to assemble. Whether delivered by comets or arising from the primordial soup, these molecules held the potential for life. This was not a conscious effort, but rather a dance of chemistry and chance. Over eons, these molecules interacted. They formed increasingly complex structures. This slow, incremental process culminated in the first life forms on Earth. Single-celled organisms, simple yet profound, emerged in the ancient oceans. These first life forms were extremophiles, thriving in conditions we would find deadly. They lived in scalding hot springs or deep within the earth, drawing energy from chemicals. They were incredibly resilient, able to survive in environments devoid of oxygen. These single-celled pioneers were the ancestors of all life on Earth. They were microscopic, yet their impact was immeasurable. For billions of years, they were the sole inhabitants of our planet, slowly but surely changing its face. Through photosynthesis, these early organisms released oxygen into the atmosphere. This was a game changer. Oxygen, initially toxic to many life forms, eventually paved the way for a new era of life. The rise of oxygen allowed for the evolution of more complex cells. These cells, called eukaryotes, possessed a nucleus and other organelles. This marked a significant leap in complexity, setting the stage for the evolution of multicellular organisms. Around 600 million years ago, something remarkable happened. Single-celled organisms began to cooperate, forming colonies. These colonies were the precursors to the first multicellular organisms. The evolution of multicellular life was a pivotal moment. It opened up a whole new realm of possibilities for life on Earth. Organisms could now grow larger, develop specialized cells, and occupy new ecological niches. The oceans became a canvas for evolution. Strange and wonderful creatures emerged. The Ediacaran biota, soft-bodied organisms of diverse shapes and sizes, thrived in the shallow seas. This was a period of experimentation, a burst of evolutionary creativity. Not all these early life forms survived. Extinctions were common. Yet from this crucible of life and death emerged the ancestors of all modern animal lineages. Section 4. The Age of Giants. The Mesozoic era, spanning from 252 to 66 million years ago, is often called the Age of Reptiles. It was during this time that dinosaurs, the most magnificent creatures to ever walk the earth, reigned supreme. Dinosaurs were masters of adaptation. They evolved into a dazzling array of forms, from the towering sauropods to the fearsome theropods. They occupied every corner of the planet, from the lush jungles to the arid deserts. The reign of the dinosaurs was not without its challenges. Volcanic eruptions, asteroid impacts, and shifting continents constantly reshaped their world. Yet they persevered, evolving and adapting to these changing conditions. The Mesozoic era was a time of giants. Dinosaurs dominated the land, pterosaurs soared through the skies, and marine reptiles ruled the oceans. It was a testament to the power of evolution, a showcase of life's boundless capacity for diversity and grandeur. Section 5. The Dawn of Humanity. As the reign of the dinosaurs came to an end, a new chapter in Earth's history was about to begin. From the shadows of the dinosaur era emerged small, unassuming mammals. These creatures, our distant ancestors, possessed a unique set of traits that would ultimately lead to our own species. Early humans were not the dominant force they are today. They lived in small groups, constantly on the move in search of food and shelter. They were hunters and gatherers, their lives intimately connected to the rhythms of nature. What set our ancestors apart was their intelligence and adaptability. They developed tools, learned to control fire, and developed complex social structures. These innovations allowed them to thrive in a variety of environments. The development of language was a pivotal moment in human evolution. It allowed for the transmission of knowledge across generations, fostering cooperation and cultural development. Humanity's journey from the savannas of Africa to the global stage had begun. Section 6. The Great Frost. Around 100,000 years ago, the Earth entered a period of significant climate change. Temperatures plummeted, ice sheets expanded, and vast areas of the planet became uninhabitable. This was the last glacial period, commonly known as the Ice Age. The Ice Age was a time of great upheaval for humans. It forced them to adapt, to innovate, and to migrate. It tested their resilience and ingenuity, pushing them to the limits of their abilities. Faced with harsh conditions, humans sought refuge in caves, developed warmer clothing, and honed their hunting skills. They learned to exploit new resources and adapted their social structures to survive in smaller, more mobile groups. The Ice Age, while challenging, played a crucial role in shaping human evolution. It spurred technological advancements, fostered social cohesion, and drove migrations that populated the globe. Section 7. Lessons from the past. As we look back on Earth's long and tumultuous history, one theme emerges. Change is the only constant. From the fiery chaos of its birth to the frozen landscapes of the Ice Age, Earth has been in a constant state of flux. Life, too, has proven remarkably resilient and adaptable. From the simplest single-celled organisms to the complex ecosystems of today, life has found a way to thrive in every environment. Understanding Earth's history is not just an academic exercise, it holds vital lessons for our future. By studying the past, we can learn about climate change, extinction events, and the interconnectedness of life on Earth. As we face the challenges of the 21st century, from climate change to biodiversity loss, we must remember the lessons of the past. We must embrace our role as stewards of this planet, recognizing that our actions have consequences that will ripple through time. Only then can we ensure a sustainable future for ourselves and for generations to come.